Okay. Hello, everyone. So, I have something new, and this time I'm doing a little different. Rather than just showing it right away in a 2-minute clip, I'm going to try to expand it out of it and talk about the things I've done. Um, so, where do I start? So, this is also off the cuff, and I'm not going to edit this at all because I lack the skill. But, um, this time, I was inspired by another YouTuber who has a program called sowon, which basically just shows the clock at the time and or a timer, and it shows it um, with like scribbled numbers. And if you know what it is, that's cool. If not, I'm sorry for the bad demo. But um, I I wanted to make my own, and this one is involved with AI. So what I do is I have the numbers generated with AI. I'm just gonna show it. So if I run it, here it is, and you can see that the numbers scribble a bit, and this is how the YouTuber tsoding did it, but um, this one is different because I made it, and the numbers are generated um, every third of a second. I did, and they're generated by AI. I'm using the MNIST data set, which is a popular data set of the digits 0 through 9, and it generates a new number for each of them every third of a second. And so currently the time is 8:38 and 30 seconds now. Um, and that's how this works. So I created a very simple data set. This will all be in the GitHub link, and the GitHub will link to this video if you're there. Um, and the data set I have, it's very simple. I didn't train it too hard. My original intent was to train something very detailed and high resolution, because it's getting colder out and I wanted to run my GPU to warm up my room. And then I realized that there's really no good data set of high quality digits, so then I would need to make my own. And I don't feel like drawing every number or every digit 1,000 times. I don't have that kind of time on my hands. My handwriting isn't also that great, so Um, but I did it. I don't know if I can find it, but I did it. Here it is. So I did a very simple generator and discriminator. This is using a GAN. It's very simple. The model is like, if we do LL, we can see that the model, I'm using Onyx. So right here, the model is only like, yeah, it's like we're only using the generator, not discriminator, because that's how these things work. You only use the generator. The discriminator is to train it and make it better. And my generator is about 6 MB, so it's pretty small on turn. It's not like 6 gigs or something. And I wanted to keep this small. Even running it like on my Mac, it's only using like 2% of my CPU while running. I like to keep things very efficient. You can even see that SOI, which is what I called it because it's so AI, right? It's only 127 kilobytes, and if we run OTOL, which is like LLD, whatever, we can see I only have a few things in here. So we have a lot of basic Mac things, which is all these system libraries. There's also standard C and system. It's required for like any Mac application unless you do fancy stuff. But then I also have Onyx runtime and GLFW. I have it rendering onto the screen using GLFW. So here's my discriminator. I probably should have shown the generator while I was talking. So as you can see, it'll be in the GitHub. It's super basic, nothing complicated. My make file is really simple too. And here's the main, and I just have it running GLFW. It should be cross-platform if you can edit the make file to do what you want. And I I create an Onyx runtime, I grab the model, and I again tried to be as efficient as possible with my code to use as little memory and CPU as possible. And I'm just every third of a second, I don't do anything, and then I'm grabbing the current time and then telling the model to generate these images with random noise for each digit and then output it. And I could probably be smarter, like, well, actually, no, I didn't want to. So I could have done it where I pre-cached them, or if I have the same digit twice, then I just only do that one. I only have to do it once, but I want each number to be random, and I'll show it again. So, not that command. I want each number to be random, and what you can do, it's just I like it better this way. It's random, right? And that's cooler to me. So it's less efficient, but it worked out better. And what else was this? So this is what it looks like running, and I should have wrote a script or something. I'm using Onyx runtime. I have it trained in Python. I have a generator, generator.onyx right here, and this is what I use at runtime. If you want to use this, or even if I wanted to make a new model because it's getting even colder, I could just create a new generator file, generator.onyx, with a different model, and even if it's bigger or smaller or whatever, I could use that to do this again. And I'd probably want to, one, make it smaller and more faster, but I would want to higher res images. I think MNIST is only like 28 by 28 pixels. I'd like something to be 256 or 512, something much bigger, so it looks nicer. 256 could probably be good. And I'd have to mess with a generator and stuff, but whatever. Oh, yeah, it's right there. And I think that's it. I'm probably going to post a few clips and stuff about this around. And I just want to keep practicing my skills of demoing what I'm doing. That's really all this is. And give reason for my crazy ideas I have that have no real purpose. But, it's just inspiration while the iron's hot. Make a project and then show it off. And then that's a reason to work on it and try to make it look as nice as possible and have the code as well documented and good as possible. And it gives me more reason to push through the annoyance of end of the project bits, like little tiny things here and there, and clean up and bug fixes and remove my to-dos, or realize I'll never get around to the to-do and then end up removing it, stuff like that. So that's all, and I hope you like it.